Okay, this is a lesson on molality. Molality is a kind of molar concentration. All right, so if you look right here, you got the number of moles of solute dissolved in a kilograms of solvent. That's important. So you're going to have moles per kilogram. Now, molal concentration is often called molarity. Molality. There's also molarity. They sound almost exactly like. As a matter of fact, the only difference is this L right there. All right. So molality is moles of solute. My line's wrong. I wonder if I move that. Yeah. So molality is moles of solute in kilograms of solvent. Amount of solutes in amount of solvent. All right. Here it is in formula ways. Okay. Little m is what we have for molality. As a matter of fact, the little m is usually italicized, but it doesn't have to be. Be careful, because what's another thing that little m can stand for?
Mass.
Mass, that's right. So little m here stands for molality. That's what's usually italicized. I usually don't italicize my mass one, do italicize my molality one. N stands for what? Moles. N stands for moles. So molality equals moles divided by kilograms. That's going to be your final unit. All right? When you have molality equals moles per kilogram, what you have to look at is the amount of solute versus the amount of solvent. Now, let's talk about that just for a minute. What's the solute? Anybody know? That's true. The solute dissolves in the solvent. So like if I have sugar dissolving in water, the sugar is a solute, right? It gets dissolved. Okay? The solvent, which is on bottom here, the solvent is the usually liquid. It doesn't have to be liquid, but liquid that dissolves the solute. Okay? The solute gets dissolved. The solvent does the dissolving. So again, in the sugar dissolving in water, sugar will be solute, water will be solvent. As a matter of fact, water is called a universal solvent because it dissolves more things than anything else because of its polarity. I do want you to notice this. Molality is important because it is independent of temperature. Moles doesn't change if you change temperature. All right? Kilograms doesn't change if you change temperature. Those are constant. In molarity, you have volume, and volume can change if you change temperature. So here, this is independent of temperature. So that means that makes it good for something called colligative properties. We haven't done colligative properties. We may not get to that right now, but this is why molality is used for that, because temperature is not affected. Okay? So what I'm going to do here is I want to go to a practice problem. Okay? Here's the problem. So we're going to calculate the molality. So we're looking for little m, right, of a solution prepared from 29.1 grams of toluene. Okay? This is in grams. Dissolved in 832 grams of benzene. That's also in grams. Now you see that both of them are in grams. So what you have to do is decide which number is the solute, which number goes with the solvent. So when you see this here, it says that toluene is dissolved in benzene, right?
What is it? The toluene, remember, is the solute.
Solute. That's right. Toluene is the solute. So benzene is the solvent. All right. So what we're going to do here, let me write the formula. All right. So the formula was molality is moles of solute in kilograms of solvent. Okay. Do I have moles in that problem? No. Can I find moles?
Yes.
Yes. Because I have 29.1 grams of toluene, I can take that and change it to moles. Because I can change grams to moles when we did our mole conversions, right? So this right here is my solute. Solvent. All right, so what I'm going to do is I'm going to say, okay, 29.1 grams of toluene, C7H8. All right, Now I'm going to look that up on the periodic table and calculate the mass of the molar mass of C7H8. Because I gave you the formula in there. You wouldn't know that because y'all wouldn't know what toluene is. But if you, that's why I gave you the formula. So I'm going to say for carbon is 12 times 7 plus hydrogen is 1. So if I add 8 to that, I get 92. So the molar mass of toluene is 92 grams per mole. So I'm going to say 92 grams of toluene per mole of toluene. So I'm going to divide 29.1 divided by 92, and I'm going to get 0.316 moles of toluene. Notice that grams cancel out. All right, everybody understand that part? Okay, good job. Now, so what we're going to do now, I have the number to go right here. Everybody agree? Okay, because toluene was my solute, I now have the moles that goes in the top of that problem. Right? So now I have to put the kilograms that goes on the bottom of that problem. Remember toward the beginning of the year whenever we were changing kilograms, grams and grams to kilograms and doing the metric system? Okay? What we're going to do is we're going to do that now. So I have 8.32, but because that's in grams, I can't put that in there. So what I'm going to do is I'm technically dividing by 1,000. In other words, moving that decimal place backwards 3 times. All right? So this, instead of becoming 832, becomes 0.832 kilograms. Remember that the bigger the unit, the smaller the number will be. So I'm increasing the unit from grams to kilograms, so I'm decreasing the number that many times. All right? So I'm going to now put that number in right there. Does that make sense, everybody? All right, so now let me do that problem. So again, so molality equals moles of solute. My moles of solute was 0.316 moles. My moles of solvent was 0.832 kilograms. All right, questions there? I'm just going to divide 0.316 divided by 0.832, and my answer came out to be 0.379. I'm going to round that to 80 because I got 0.3798, so on. And my unit can be moles per kilogram, or is also acceptable to put 0.380 little m. That little m stands for molality, so that's acceptable. Let's check something though. Let's check our problem. 3 significant digits, 3 significant digits. So my answer is in 3 significant digits, and that's correct. All right, good. Okay. So now let's go to another example. All right. So here's example number 2. Example number 2. When we look at this one, we have how many grams? So we're looking for grams of sulfur is dissolved in 200 grams of naphthalene. There's the formula for that. And I want to make this much of a molar solution. Now, this is different from the problem before because in this time I'm giving you molality, and I want you to find the grams of the solute. Right? Everybody understand? So what I'm going to do here, again, let's think about it. So sulfur is my solute. Does everybody agree with that? Because it's the one that gets dissolved. So this is my solute. And my naphthalene is my solvent. All right? So again, the formula, molality equals moles of solute, kilograms of solvent. All right? I already know my molality, and I can very quickly get my kilograms, right? Okay, so my molality was 0.23, and I'm going to go ahead, I'm going to write it like this so you can see the units cancel out, right? Because little m is the same thing as moles per kilogram, correct? Everybody agree with that? Equals my moles of solute I do not know yet, correct? I can't get that because I don't know what sulfur is. So I'm going to put X for that, divided by my kilograms of solvent. Can I get my kilograms of solvent from this?
Yeah, you gotta move that.
Yes. I'm going to move that number to, instead of being in grams, I'm going to move it to kilograms by changing that decimal, moving it back 3 places. So instead of being 200, that becomes 0.2000 actually kilograms. All right. Now, so what I'm going to do now is what? Mathematically. I'm going to multiply both sides by 0.2. Does everybody agree with that? So I'm going to say 0.23 times 0.2, and that gives me 0.046. And when I multiply by that, what canceled out? The kilograms will cancel out. So that gives me moles equals X. Now, does that answer my question? No. Because when I do that, I have moles, I want to find grams. So can I go from moles to grams?
Yes.
Sure. All I have to do is do my my mole conversion. So I'm going to say 0.046 moles of sulfur, which was, the formula was S8. I'm going to look that up on the periodic table. All right. So sulfur is 32 times 8, 256. Now, in this case, since I want mole to cancel out, right, I'm going to put my 256 here, grams per mole. So mole cancels out. Does that make sense? So I'm going to say 0.046 times 256, and my answer comes out to be 11.78 grams. Let's go back and look at our significant digits here. In the problem, I have 4 significant digits and 2 significant digits. I have to go by the least, right? So my answer can only have 2 significant digits. So what would my answer be? 12 grams would be my answer. Yes? Yes. How to review solute and solvent. Okay. The solute is what gets dissolved. So the solvent is the substance that does the dissolving. Okay?
So solid gets dissolved.